Hi YouTube, I hope you all guys are doing great. This is the second video of Langchain basics. Previously, we have seen introduction to Langchain, prompts, chains, agents, and memory. Now, in this video, we are going to see some more basic stuffs like embeddings, chunkings, vector store retrievers, RAG app, and a special homework for you after learning about the RAG app. So, in embeddings, we are going to see how actually the whatever data we are having, how we convert it into vectors, why embedding is important. There will be two options, like you can also use OpenAI as well as your Hugging Face um, models to create Hugging Face embedding models to create vectors. So it's not necessary that you, if you are having an OpenAI key, then only you can process. Even if you don't have any OpenAI key, because it takes some amounts to pay like $20 or something. So if you don't have that money, also you can learn about it. You can use open source models. Then we will see the chunking, how chunking happens, what are the chunking strategies. Then we will learn about vector store, what is vector, or why we need vector, why we actually why we convert into vector, how we convert the text into vector, how we convert images into vector, and how we store it into vector store. Different type of vector store also we will explore. Then we will see a retriever, and then we will combine each and everything whatever we have learned in the whole basic, and we will create a RAG based application where there will be two documents, both will be PDF, and it will be a new PDF which on which the GPT 3.5 turbo model is not trained, which will be some privacy policies document. And then we will use that some chunking strategies, and we will chunk it, and then we will embed it, and we will store it into some vector store. And then we will use some of the retrievers, and also we will use some RAG chains, which is very important. We will not use the LLM chain, which is a basic chain. And then we will also use React agent, which is a very good agent. So we will use it, and then we will form a whole chatbot where we can put our queries and query, and then we can retrieve the documents from that whatever documents or whatever content we are having. Okay, so and definitely we are not going to build the front end part of this RAG app towards the backend. So if you want to also bring the front end, you can use a Streamlit or Chainlink that I have also talked in the RAG app part. So that's very easy. You don't have to take care a lot about the front end. So you can use this service, and you can also bring a front end, and you can flex with your friends. And then we will have a homework also. So I hope you will enjoy this thing. And this is if you cover this two videos, then I think that you will be good at the basics of Langchain. And definitely a lot of different topics are there which should be covered, but I think this much topic is enough to for being a starter to the Langchain and LLM world. So I hope you will cover all of them, and you will learn a lot of things. And definitely, it's not just a theory video. You can find all the practical stuffs in the notebook, and I will also share this link. GitHub, I will the GitHub link of this collab in the description box, where you can find all these things, the practical of embeddings and chunkings, different type of chunkings, vector store, retriever, and RAG app. So it's going to be a very good session where you will get the theory as well as the practical knowledge. I'll meet you in the next section, which is embeddings. In this section, we are going to see about embeddings. Embeddings is a very important part of whatever LLM application you are trying to make. Okay, so once let's see what actually is embedding, you will understand the real meaning of embedding and real use of embedding. So word embeddings are a way to represent word or phrase in natural language processing as vectors of real numbers. These vectors are used to capture the semantic and syntactic similarity between words in a high dimension space. Okay, I'm not talking about 1D or 3D, it's ND, like high dimension, like a lot of dimensions are there. In this context, words are represented as vector in this high dimensional space, with each dimension corresponding to specific feature. It can be like living being, feline, human, gender, whatever it is. Each word is assigned a numerical value along each dimension. Typically, the distance is between minus 1 to 1. The range is somewhere like minus 1 to 1. Okay, and sometimes it also depends upon the embedding models, indicating the degree of association with that feature. For example, the word cat might have a high positive value in the feline dimension. Okay, because this feline and cat, I think they both are of same class. Okay, but um, and the value close to zero in the human dimension, like cat and human are far away. Okay, so they will be having no similarity between both. Okay, so reflecting its strong association with the felines and lack of association with the humans. The numerical representation enables us to capture semantic relationship between words and perform mathematical operations on them, such as calculating word similarity or using them as input for machine learning models in NLP tasks. Real life examples can be like, imagine you have a data set of movie reviews and you want to analyze the sentiment of each review. By converting the words in the reviews into word embeddings, you can train a machine learning model to predict the sentiment, positive or negative, what it is, based on the context of word used in the review. Okay, it's very, very easy. Okay, let me show you a simple demo. You will understand each and everything. Okay, there is no means of talking so much about the theory of it. Okay, so this is the embedding section. So here what we have to do is just we are importing the just we are adding the OpenAI key because we are using OpenAI embeddings, and this is not uh, compulsory. Okay, if you don't have OpenAI key and you don't want to use OpenAI embeddings, that's fine. Okay, it's up to you. You can also use free embedding models like Hugging Face. Okay, so what actually we are trying to do is, so whatever text we will be having, okay, in future you are going to have a lot of different text. Okay, here we are just taking a sentence, but in future you might be having doc of text, whatever it is. Okay, so we have to pass it through some of the embedding models. What this embedding model does is they convert this text into embeddings. Okay, and what are embeddings? Just we have seen, embeddings are just the numerical representation of this textual one. Okay, so there will be some numerical representation of this. Okay, this is a simple one. Why we are converting into this numerical representations? Because to show the association, like cat and feline will be close, human and cat will be far away. Okay, so let's see the demo. Okay, so here I am just using OpenAI embeddings. So if I print the embeddings here, okay, this is just we are importing OpenAI embeddings from Langchain OpenAI because we want to use OpenAI embeddings. So if I am printing the embeddings, like if you want to see which model I am using, so here you can see by default it uses text embedding ADA 002. Okay, this is the embedding model. You can use any kind of embedding model. Okay, now this is the sentence or a query that basically whose embedding we are trying to find. Okay, so query embedding is equals to embeddings dot embed query. This is just a syntax, and we will pass whatever text it is to convert it into embeddings. So if I print the embeddings here, you can see this is the numerical representation of this sentence, which is cat is very angry. So here you can see it says a lot of dimensions. Okay, so the length of query embedding is 1536. So there will be 1536 this kind of numbers, 1536. Okay, and this length obviously differs from the embedding model to embedding model. Like here only we are using sentence transformer because to use this Hugging Face embedding models we need this sentence transformer. So that's why I'm installing sentence transformers, and then we are using Langchain community.embeddings, and from that we are using Hugging Face embeddings. Okay, so we are using this Hugging Face embeddings, and basically now we can directly use some Hugging Face embeddings. Okay, so and this is actually free of cost. Okay, you don't need any OpenAI key. Now the same query, which was this cat is very angry, so I'm converting it I'm converting it into embeddings using Hugging Face embedding models. So here it is, I'm printing it. So this is the embeddings. So now we have used Hugging Face embedding model. So that's why the length is 760 dimensions. But here it was 1536. The length of query embedding that has been generated by OpenAI embedding models was 1536. So it depends upon model to model. Okay, and you can use any kind of model whichever suits you. Okay, if you find this OpenAI embeddings better, you can use this. If you are trying to use Hugging Face embeddings, that is also good. Or whatever, if you are having different models, you can also specify the model name. Okay, so that's fine, that's up to you. Okay, so what actually embedding is, we have just seen like whatever text we are having, we have to convert it into numerical representation, real number representations using embedding models. Okay, now what happens whenever you convert like this, you store it in a vector store, and then in this vector store we actually um, query some information as input and we get some output. Okay, so that's why embedding is a very, very important concept. Okay. In this section, we are going to see some chunking strategies. First of all, let's see what actually is chunking. Chunking is basically a process of breaking a document into smaller, semantically meaningful pieces. This helps to preserve context and allows for better embedding of long documents. So it's something like this. Let's suppose you are having a very long document having a lot of text. So we have to divide this into smaller chunks, okay, which will be having some semantic meanings. Like there were 5 different parts, so we are converting into 5 different chunks. Okay, imagine in a TV show The Office, chunking the transcript into sentences helps to capture the context of each scene, which is likely what a user would search for. Okay, so we don't want this whole document to be inserted directly into vector store. Okay, first of all, we break it into parts, and then we pass it into embedding models, and we get the embeddings of it, and then we store it into the vector store. Okay, so this is how a flow works in a RAG pipeline also. So that's why chunking strategy is very, very important whenever we have to break down a document into smaller section. Now, it's not that easy. How to chunk? So consider your content type like books, articles, or product descriptions. Understand your embedding model limitations. Consider the applications of retrieved results like semantic search, question answering, whatever it is. Okay, based on these things, you have to basically decide which chunking strategy you have to use. So, for example, one of them is fixed size chunking. Okay, so by the name, I think you might be able to relate. Like it divides the file into equally sized segments which overlap to preserve context. Okay, and let's see. Actually, if I give you an example, you will understand it better instead of saying something. So let's see what actually Fisk site chunking is. So here is a text. Okay, this is a very basic text. You can also have some documents, HTML file, whatever it is. Okay. Now we are using character text splitter. So this is what fixed chunking is. Okay. So the separator is \n. So what actually is separator? It's the string used to separate chunks in the text. In this case, \n means that chunks will be separated by two new line characters. If there are new line characters, we will convert into different chunk. Okay. Then chunk size is 1000. Means the maximum size of each chunk in terms of characters will be 1000. Like chunks larger than this size will be split it into smaller chunks. Here the chunk size is set to 1000 characters. Then we are having chunk overlap, which is 200, means the number of characters that will shared between adjacent chunks. This helps preserve the context between chunks. In this case, there will be an overlap of 200 characters between chunks. If you don't understand what actually is overlap, so it is overlap. Like let's suppose I am giving an example. Cat is, now this is will this is, let's suppose, one chunk. Okay, cat is blue in color. Okay, so we are having 4 chunks, but this is basically overlapping. Okay, this is again coming in, the same text is also coming in the first sentence on first chunk, and it is also repeating in the second chunk. So this is what actually overlap is. Okay, and it is important to preserve the context. Okay, but sometimes might be some cases where you don't want overlap, so it depends upon use case to use case. Okay, then we are having length function, which is length. So a function that determines the length of a chunk. Here the length function is used to calculate the length of chunk based on the number of characters. Then we are having is separator regex, which is I have made false, so a boolean value indicating whether the separator parameter is a regular expression. If it is set to true, the separator will be treated as a regular expression pattern. Here it is set to false, indicating that the separator is a literal string. Okay, simple. You can also miss some of these parameters. Okay, these three are very, very important. Then we have created a method, so we are calling it like text splitter dot create documents. This is just a simple syntax, okay, and we are passing the text because we have to convert this text into chunks. Okay, now I'm printing one of the chunk. So one of the chunk is like this. Here you can see like against crime. So here somewhere there should be against crime, like mm, mm, mm. See, first sentence is one of the chunk. Okay, so length of chunk is 2. So I think first chunk will be this one, and then the next chunk will be the remaining one. Okay, so here you can also see the length of the chunk, and the length of the chunk also depends upon whatever chunking strategy you are applying. Okay, so here you can see overall the this character text splitter was configured to split into chunks of 1000 characters each with an overlap of 200 characters between chunks using backslash n and backslash n as operator. Okay, you can also use some documents to split and see the results. Okay, now let's see the recursive text splitter. So it is used to basically split recursively by separators preserving the context. So here you can see like we are using Langchain splitter, and we are calling recursive text characters text splitter where the chunk size is 100. I have just kept the chunk size as 100. Chunk overlap is 20. Here the chunk overlap was around 200. Okay, then the lang function as same is separator regex, which is false. So this is how you can also use the recursive text splitter. So just we are using text splitter rack, which is the name here it is, dot create documents, the same, okay, the same way you can use any text splitter, okay, and then you are getting the chunk. So totally there are 19. Why? Because we have just reduced the chunk size 200. Here the chunk size was 1000, so here it is one of the chunk. Okay, so the length of chunk is around 90. Okay, now there is one of lot of different chunking strategies are there. You can go to text splitters and you can read like there are a lot of like recursive, HTML, markdown, code, token, character, experimental, which is semantic chunker. Okay, like whenever sometimes you will find some use case where you have to use metadata to the your chunking strategy. So then you can use this HTML markdown. Okay, you can learn about this, and each of this also given very beautifully here. Okay, so you can read about it. Okay, just go to the Python, this pythonlangchain.com, and docs, modules, and data connection under document transformers, or just search for text splitters in Langchain. Okay, this is one of a very good chunking which I also like semantic chunking. So let's see how you can use it. Or before, let's talk about what actually semantic chunking. So at a high level, this is split into sentences, then groups into groups of 3 sentences each, and then merge one that are similar in embedding space. Okay, so basically first of all it will be converted into a group of 3 sentences each, and then merge one by one that are similar in which fits into a same embedding space. Okay, so how we can use it, just it is inside Langchain experimental.text splitter. You can import this semantic chunker. Okay, and if you want to read more about it, you can also go to here, which is semantic chunker. Okay, which is in experimental phase, so it is in experimental uh, package. So text splitter same is equal to semantic chunker. Here you have to also pass the embeddings. So this embeddings is basically OpenAI embeddings that I have already used in this embedding. Okay, just you have seen in the previous section. So this is the embeddings. I'm just using OpenAI embeddings. You can use any kind of embeddings. Okay, uh, no need to pay some money to learn Langchain. You can use Hugging Face, which is very ultimately very completely free. So chunk sam, which is just I'm giving a name, text splitter dot create documents. On the text is also same. Okay, this the Batman text we are using again and again. Okay, so here we have used like Batman, also known as Dark Knight, is a fictional superhero appearing in American comic books. So this is also one of kind of chunking strategies. The real power of chunking you can see whenever you will create a RAG application where there will be a lot of documents, and then you have to use this chunking strategies. If this text is very small like this, you will not find any like you will not feel the power of chunking, okay, and you will not feel that okay, any kind of chunking strategies, I don't have to care, I can use only recursive text splitter every time, or I have to just every time use this fixed type chunking. That's not a matter of fact, but it's not like that, okay. It's highly depend like what kind of document you are having, how complex document you are having. If you will face this, then only you will able to know that okay, chunking strategy is also very important. I have to, it's a very important and also sometimes very complex to decide which chunking strategy we have to follow depending upon the documents, okay. So in this semantic chunker, also there are some other things like there are breakpoints in semantic chunking. Semantic chunking involves breaking text into smaller semantically meaningful parts based on the differences in embeddings between sentences. This process is crucial for tasks like document summarization and semantic search. There are several methods to determine when to split the text into chunks, each with its own threshold setting approach. Okay, like this semantic chunker also provide this breakpoint threshold type. First can be the percentile one. So the percentile, this method splits the text based on the percentile of difference between sentence embeddings. For example, if the threshold is set at the 90th percentile, any difference generate greater than what 90% of all difference between sentences will trigger a split, and then the split will happen. This method is useful for capturing significant changes in context between sentences. Use this when you want to capture significant changes in the context between sentences. Example, like summarizing a long article where major shifts in topic occurs. So you can, and some more are also there. Like this is a percentile one. You can also find the standard deviation method, and also you can find the interquartile method, and also this standard deviation, okay. And you can also go to this somewhere like, I guess it is somewhere here, like semantic chunking. So here you can find this breakpoints like percentile one, so you can use percentile or standard deviation, or you can use interquartile, okay. Have just shown this percentile one. So we have just we have not done any like semantic chunker embeddings. We have just passed the embeddings. Initially we were just passing embeddings, but we can also now pass the breakpoint threshold type. And then we can, the rest is same, like we have to always call the text splitter dot um, create documents. I think I have just done a mistake, like text splitter, it should be like this one, text splitter same percentile, it should be like this, okay. You can just run it, okay, it's not a big deal. Dot create documents text, and this one same, okay. If you want to read also, you can read here, okay. We are just doing the same, like open we are calling this threshold type, and then again create documents, and we are passing the text whatever we have to see, okay. Then again I'm just calling the chunk semrec the first one, and I'm getting this one, okay. There are two other methods also, interquartile and standard deviation. So standard deviation, here the text is splitted based on the number of standard deviations away from the mean difference between the sentence embeddings. A higher standard deviation threshold will result in fewer and larger chunks, while a lower threshold will create more or smaller chunks. Okay, this method allows for more flexibility in determining the threshold based on the dataset characteristics. When you should use it, like use when you want more control over the size and the number of chunks. Example, like analyzing a dataset where with varying sentence lengths when you want to balance chunk size and context. And interquartile method, it's like the difference between 75th and 25 percentile. Okay, it is used as the threshold for splitting text. This method is robust against the outliers and can be good balance between capturing significant changes in context and avoiding excessive splitting. Use when you want like a robust method that is not affected by outliers. Okay, like summarizing a document with occasional off-topic paragraphs that shouldn't be affect the overall chunking. Okay, so that's the case, okay. Like if I give a so you can also play with it, like just change this percentile into interquartile standard deviation and see what is happening. And same for all things like chunking, and every kind of chunking. Like take a document, okay, take a basic document, basic PDF, okay, or basic text file, and see how you can perform chunking in it, and see what are the results when you are doing fixed text chunking, what is the result when you are doing recursive text splitter chunking, or what is happening when you are semantic chunking, and also play with this breakpoint threshold type, so that you can see like what is actually happening. And you can also increase your level, like first of all choose a very basic PDF, then have some maybe some complex documents like some legal documents, and try to perform checking on it. Okay, if I combine all these three methods where you have learned about this percentile, standard deviation, and interquartile method. So if you are summarizing like a speech like the State of Union address, where the topic shifts occur at a predictable intervals, when there will be a predictable intervals, like example when the speaker transition to a new policy area. So you might use the percentile method with a very high threshold to capture those major shifts. If you are analyzing a legal document with long, complex sentences and you want to ensure that each chunk contains a manageable amount of information, you might use the standard deviation method with a threshold that results in smaller and more frequent chunks. If you are summarizing a research paper with occasional technical sections that require more detailed analysis, you might use the interquartile method to ensure that these sections are captured in the entirely without affecting the overall chunking. So basically, there are no one size fit all strategy. Okay, experiment with different approaches to find what works best for your content and use case. It depends upon use case to use case, but this both embeddings and chunking strategy is very important, because this is a very integral part, or you can say the basic part of performing or making a LLM powered app, or to store the data into vector store. And vector store are the heart, because they are the database provider, they are the source for the RAG pipelines. So that's why embeddings and chunking strategies are very basic things. Sometimes people don't understand it, just they overlook it, but this is also very important. Okay, and please follow this one, where a lot of time new text splitters are being added. So keep just a look into it, like split by tokens, so you can see stick tokens. This is also very important, so you can read about it. I can't cover each and everything in just a video, so you can go and read all these text splitters and have a look into it, and also have an eye on this documentation, because a lot of new experiments, this is a very new field, LLM based app, and this Langchain framework, this very in a baby stage. So a lot of new things are being added, so you can have a look on into it, and whatever new advancements are going on, this even in just a text splitter section also you can adapt it. Okay, so that's it in this section. In this section, we are going to see about vectors. So first of all, let's see what is actually a vector. Vectors are like containers that hold information in the form of numbers. Like imagine you have a box that can store many different types of things like numbers, words, pictures, sounds, and many more. Each item you put into the box is assigned a number. Okay. This box is a bit special because it can hold not just one but many numbers at the same time. These numbers are arranged in a special way, forming a structure that helps us to understand and work with different kinds of information. Okay, so whatever text you are having, it will convert it into some numerical format. Okay, so what can be converted as vector? First of all, let's see text. Imagine you have a long list of words from a piece of text. You could turn this list into a special kind of list called a vector, where each word gets its own spot in the list. Now, for each word, you count how many times it appears in the text and write down the number in the corresponding spot in the vector. This is called a bag of words representation, because you are just throwing all the words into the bag without worrying about their order. But that's a problem with this approach. The vectors end up being mostly filled with zeros, because most word doesn't appear very often in any given text. So we have come up with a very smarter ways to turn the text into vectors. One popular method is called word embedding. Okay, we have seen what actually embedding is. Instead of just counting the word embedding creates a compact vector that not only take up less space but also capture the meaning of the words. This means that the words with similar meanings end up being closer together in the vector space, making it easier to understand the relationship between them. We have seen in the embeddings what actually happens, like there are some words, sentence like this is a cat, and it converts into some numerical data like maybe in 568 dimension or more depending upon the models. So the um, words which are more semantically closer have less distance between themselves. So first of all, we can store text as vector. Now, can we store image as vector? Yeah. Image can be thought of as a grid of teeny squares like which we call as pixels. So where each square is called pixel. Each pixel has three numbers associated with it, which represent how much red, green, and blue. Why you might have heard like RGB, so red, green, blue, because these are the primary colors. So each whatever like every pixel is associated with three numbers like RGB, the value of RGB. These numbers can range up to 0 to 255, where 0 means none of that color is there and 255 means the maximum amount. For example, we say we have a small like 4 by 4 pixel image. We can represent this image as a grid of numbers where each number represents the color of a pixel, like maybe a lot of pixels are there. So first of all, there is 255 into 0 into 0 means completely red color, then 0 to 55, 255 to 0 like completely green, and so on. Okay, and like that, if it is 128, 128, 128 means the equal combination of red, green, blue. Okay, in this example, each tuple of this is actually a tuple of three numbers represent the red, green, and blue values of a pixel. The first pixel, for instance, has a full red like 255, then no green, like only the sorry, there is completely green, then maybe one of them will be having completely blue. Or if the value of RGB is 128, 128, 128 means the combination of all three colors taken equally. Okay, so um, why we are converting into vectors? Okay, like data is represented as vectors in machine learning because vectors offer a neat and organized way to store information. Each element in a vector can represent a different aspect or feature of the data, making it easy to work with and analyze. So machine learning algorithms often require programming mathematical operations on data such as adding, subtracting, or finding the dot product. Vectors allow these operations to be done efficiently. Okay, so additionally, representing data as vectors allows for the use of linear algebra also, like which is very fundamental in many ML algorithms. So linear algebra also provides powerful tools for manipulating vectors and matrices, enabling algorithms to analyze complex data set and make accurate predictions. Overall, using vectors as a data representation in machine learning simplifies the computation process and helps algorithms learn more data efficiently. That's why we store, uh, that's why we convert our data into vector, whether it is text or image. Okay, so after the data is transformed into vectors, it's often processed by a pre-trained machine learning model to map these vectors into a new space where similar objects are close to each other. This mapping process is called embedding. Okay, we have seen what actually embedding is. Okay, so um, and the resultant of these vectors are called as embeddings. Okay, embeddings enable a powerful concept like the similar items in the original data were represented by vectors that are close to each other in the new space. This means that to find similar items to a given item, we can simply look for all the vectors close to the vector representing given item. Okay, like simply what actually happens is like let's suppose we are having some data. Okay, so let's suppose we are having some data. So first of all, we will have some feature vectors. Okay, where this data will be converted into numbers, then it will be passed to some of the ML model, and we will form some embeddings. Like we have seen what actually embeddings are. Okay, we will form some embeddings, and then we will store it into the vector store database. So actually vector store is a database where we store the vectors, not the raw text. Okay, So let's see what actually vectors are in action. So here is a section for vector store. So we are using face CPU. Okay, you can use anything, Milvus, ChromaDB, whatever vector store. Like it's like you are having some data and you can use MySQL, or you can use like any database provider, whatever you want. Okay. So in the similar manner, face CPU is a vector store. Okay, you can use any kind of vector store. Okay, then I'm installing Langchain. Okay, then how we can basically store something into the vector store. So we have seen what we were doing. We were having data and then we convert it into embeddings. So we know how we can convert it to embeddings. So here is our text. Okay, this is a text. This is just basic information that I have extracted from, which I have generated from ChatGPT. Okay, this is just a imaginary company which is XYZ Corporation, and we have some information about it. So first of all, we are splitting. So why we are splitting? Because if you are having a very long text and if you split it, so it is better that the model will correctly identify it or correctly understand it. Then we have split it by using character text splitter. If you don't know about splitting and all, so we have seen in the previous video where we have talked about embeddings and chunking. Okay, so we are using just a character text splitter, like the each chunk size will be 100 and the overlap is of 50 characters. So this is the chunks. Okay, so this is the text for which we are doing chunking. And if you see, this is all the chunked text. Okay, so there are total 4 chunks. So we have divided this whole text into 4 different chunks, each would be having 1000 of characters. Okay, so now this is how we form a vector store in this phase. Okay, now it depends upon your db to db, how you operate it, how the syntax is, but the functionality is same. Okay, first of all you have to convert this text into, you have to split it, you have to make the chunks, and then you have to pass that chunk data to here, and also embeddings. What actually embeddings is here? So basically in this embedding section, I have created like the OpenAI embedding. So I'm using OpenAI embeddings. If you don't have a OpenAI key, you can also use Hugging Face embeddings. Okay, so I have also shown how we can create Hugging Face embeddings in the embeddings video. So you can use it simply. Okay, so we are passing the chunks as well as the embeddings, and then it will store the vector, store it into the vector store. Okay, all the embeddings will be stored. Okay, all the vector store will be stored. Okay, now we are having a question: what is the reason for XYZ corporation success? Okay, so the answer would be somewhere here. Okay, whenever we are asking some question in this vector database, it will not create a new answer. Like in ChatGPT, it generates some new question. Sorry, new answer. It's not like that. Okay, it will just take the same section. Like if I search this thing, okay, just I have copied it, and if I search it here, it will be same somewhere here only. Okay, so here you can see like in the bustling world of international commerce, so it is there. Okay, in the bustling world of international commerce, here you can see it will just um, like there were 4 chunks. Okay, so it will check in which chunk is more closer. So how we can check it? This is like similarity, db.similarity search with the score. If you are doing this, then you will also get the score, and if you don't want to get a score, you can also remove the score. Okay, just here you can see 0.29, so the answer is very close, okay, to the origin. Okay, so that's why, so we have printed the answer. Okay, so this is where what is the reason for XYZ success? So definitely this is the beacon of innovation and success. Okay, so that's why it's getting it closer. Then if you see like again we have asked a question like who is Bill Gates? Okay, so who is Bill Gates? So sorry, who is Bill Gates? Okay, who is Bill Gates? So here you are getting another one of the answer, but if you see the similarity search with the score, so it also gives a score which is 0.5, means the distance of this document that we have just received is a very far away, okay, from the origin. So this is not a if the distance is much far means the answer is not closer, and if it is not closer it is not exact. Okay, if the distance is very close to the origin, like here 0.2, it means that whatever question you are asking and what are the documents or the answer you are receiving, it is actually correct. Okay, because if it is very far, then it doesn't make sense. You will get every time some answer, okay, because we are just doing similarity search. Okay, so every time you will get an answer, but the score is very important. If the score is very far, like in this case it was 0.5, so you can say that okay, the answer is not correct, but here you can see it is 0.2, so it means that the score is closer. Now you might be seeing some more documents I am also getting, yeah, because we will see like the value of k is um, by default it retrieve four documents. Okay, it retrieves four documents if we are not specifying the value of k. Okay, if we specify the value of k, then let's suppose we want only two documents, then the k value will be 2, but by default it is 4. Okay, so this is how we store the data into vector store. Lot of things you might be seeing from the previous video, how we convert it into chunks, how we pass the embeddings, how we create the embeddings, and now this was the part which was new, like phase from four documents. Okay, and definitely the syntax depends upon the db to db. Okay, then how we ask a question, how we check the similarity search with score, or you want to see something new, so you can just go and here db dot and just wait for some moment, you will see a lot of pop-ups. Okay, so that's it. Now let's see what actually there are some use case of vector store. So vector search has several valuable use case in various fields. Here's like some examples. Let me tell you. Like first one is semantic search. So this involves searching for documents based on the meaning of the search query and the content of the documents. It goes beyond simple keyword matching by understanding the context and intent behind the query. And the content being searched. Semantic search is used in search engines, recommendation systems, and information retrieval system to provide more relevant results. Then second can be like reverse image search. Like this allows user to find images that are similar to a given image, as you have seen in Google Lens. It is commonly used in search engines like Google Images, where users can upload an image or provide a URL to find similar images on the web. Then also recommendation engines like other system uses vector representations of items such as product, movies, or articles, and user preference to recommend the relevant items to users. For example, social media platforms uses recommendation engines to suggest post, video, or products based on a user's previous interactions and preferences. Then some these are some examples, basic like how vector search can be applied in different domains to improve search and recommendation system, enhance content discovery, and detect similarities between data points. So you can also practice about this vector store. What to practice? Just you have to know how we store the data into the vector store and how we query from it. Okay, like if you want to see the score, what should be the method? If you don't want to see the score, how we can show it? So just search for vector store Langchain and you can easily get it. Okay, here you can see a very good document if you are using Chroma, how you can store the data, how you can do similarity search. If you do this type of similarity search, you will not get the score. But if you are doing like similarity search with score, you will also get the score. Here there is no score. Okay, it depends upon your use case. Okay, then if you want to use phrase db, this is how you can use it. If you want to lens db, this is how you can do it. There are a lot of other vector store also are there, like Milvus, Pinecone. Okay, so you can also explore it. They are open source, I guess. Okay, so here you can study about the vector store. In the next section, we are going to learn about retrievers. In this section, we are going to look about retriever. A retriever is a component that takes an unstructured query as input and returns a relevant documents. Unlike a vector store, a retriever doesn't necessarily store documents but focus on retrieving them based on the query. So while vector stores can be used as a part of a retriever implementation, there are other types of retrievers that uses different methods to retrieve documents. In summary, like retrievers are more general and focused on returning documents based on queries, while vector store are specifically designed to store and retrieve vectors representing documents. Okay, This is very easy and small topic. Like here you can see in retrievers. So this is a DB. In just previous section, we have seen how we can create a phase DB. So if you want to ask some, this is how you declare or initialize a retriever. Okay, db.as retriever. Now if you want to retrieve something, just use this retriever and dot get relevant documents, and then just pass your query, whatever is your query, like what are corporate social responsibility initiatives of XYZ company. Then whatever results you are having, you can print it. So here you can see at XYZ corporation we are committed to driving positive change in the world through our initiative, innovative products and sustainable practices. Okay, this kind of, so this was their social responsibility. This is here also, if you want to just search, you might get it. Okay, see, this is corporate social responsibility. Okay, this is the first answer. Okay, and now again I'm telling you, you are getting four documents: one, two, three, four. Why? Because by default, this retriever value is set as k is equals to 4. Okay, like there are like such quarks, and you know how you use quarks. Okay, so the value of k would be 4 by default. Okay, if you want only two documents, then you have to set the value as k is equals to 2. Okay, so this is how it happens. Okay, now if I ask some different questions like who is Bill Gates, what is space, still I will get four documents. Okay, but the score here, I'm not showing the score, but if you show the score will be very far. So it's not important by using this vector store that okay, if you are asking something and you are getting some answer, then it might be correct. No, it also depends upon the score. If the score is very high, it means that whatever documents you are fetching from your query is not relevant, it's not close enough. Okay, so this is very simple retriever. Okay, you don't have to worry a lot about it. Okay, if you go to here and just search for retrievers, so vector store backend retriever, here you can see how retriever works. This is a simple, you have created a retriever and you are asking, simple. Okay, then you can also do a lot of things here. Okay, this is what I was telling you, db.as retriever, and you can pass search quarks is equals to k is equal 1. If you are doing 1, then whatever documents you will be retrieving, it will be giving only one document. Why we are getting 4? Because by default the value of this search box is 4. Okay, by default it is 4. You can set to 1, 2, 3, whatever you want. Okay, then a lot of other queries are a lot of other retrievers are also there, you can learn about it. But the basic, you can say, the soul of retriever is what I have just explained you. Okay, this is a very simple topic. Now in the next section, we are going to see the whole RAG based application, how we can build it. That we have already just uh, learned all the basic things whichever we need to create a RAG application. It can be embeddings, the conversation, because the memories, agents, because we also want to have a conversation flow, then the chunkings, vector store, retriever. This is it. Okay, all the building blocks are now ready. Now we can create our own RAG based applications where we will be having a PDF, different source of PDF, and then we can create a chatbot where we can chat with that document, which is an external document whose information will be not even in the open AI or any models, because they are not trained on our proprietary data. So we can load it, we can create the vector store around it, then we can have a chatbot like feeling where there will be conversations, there will be history and all. Okay, so meet you in the next section. Hi. In this section, we are going to see about RAG. So RAG stands for Retrieval Augmented Generation. You might have seen a lot of apps, LLM-based apps are now building upon RAG. So a lot of chatbots you might be encountering in day-to-day life, they are based on the RAG. Okay. So the full form is Retrieval Augmented Generation. Basically, it is a concept that enhances LLM by providing them with additional information from an external knowledge source. This enables them to generate more accurate and contextual answers while reducing factual inaccuracies known as hallucinations. For example, like you might have seen that ChatGPT is able to answer all of the questions on which it has been trained. Okay, but let's suppose you are having some information about your office. Okay, and you want also to create a chatbot as good as like ChatGPT, which is having so much reasoning capability, and but your office data has not been trained on the by the chat gpt. So how you can perform it is by this. The answer is the rag. Okay, so state of the art llms are trained on vast amount of data to acquire a broad spectrum of general knowledge stored in their neural networks weights. However, when they are prompted to generate completions that require knowledge not present in their training data, such as near or proprietary data like your office data or domain specific information, they may produce inaccurate answers or hallucinations. So you might have hearing a word called hallucination. What actually hallucination is, like to create something which never exists. Okay, if you ask ChatGPT some information on which it has not been trained, so there is a chance that it will hallucinate and it will give some false answers. Traditionally, adapting neural networks to domain-specific or proprietary information involves fine-tuning of the model. While effective, this approach is intensive and costly and requires technical expertise, making it less adaptable to evolving information. Okay, but in 2020, there was a paper. It introduced a more flexible approach called RAG, Retrieval Augmented Generation. In the paper name is something Retrieval Augmented Generation for Knowledge Intensive NLP Task. You can find it online. These techniques combine a generative model with a retrieval module, enabling the model to access additional information from an external knowledge base or a source that can be easily updated. To illustrate, consider an open book exam for humans. In an open book exam, students can bring reference materials such as textbook or notes to look up relevant information to answer the question. Similarly, RAG separates the factual knowledge from the LLM's reasoning capability. Factual knowledge is stored in an external knowledge source, non-parametric knowledge, which you can also say, which can be readily accessed and updated while the LLM focus on the reasoning. Because this LLM means ChatGPT is not an LLM. It uses GPT 3.5 or 3.5 Turbo or 4. This is LLM. It has a very good reasoning capability. So we want to use that reasoning capability. Okay. So this is it about RAG. So if you see, R is for retrieve. Okay, so the user query is used to retrieve relevant context from an external knowledge source. To do this, the user query is embedded with an embedding model into the same vector space as the additional context in the vector database. This allows for a similarity search, and the top k closest data points or data objects from the vector database are returned. And then for A, we call as augment or augmented. So the user query and the retrieve additional context are then combined into a prompt template, which is called as augment. And then we have G for generate. Okay, so finally the retrieval augmented prompt is fed to the LLM for generating the final output. Okay, so what are the prerequisite for this RAG? We have already seen all the prerequisite because in the previous video and in this video we have learned a lot of things. All they were the building blocks for this day. Okay, this is the day. Okay, now first we are using Langchain for orchestration to connect all the dots, and then we will use OpenAI for embedding model and LLM. You can also use Hugging Face models like Google's 95XXL, which I have already shown you. And then you can use phase db. We are going to use phase db. You can use any kind of vector db that also we have seen in the previous video. So what actually it looks like, let me give you an overview so that you can understand it better. So I will try to draw a diagram on it. Okay, so first of all, we will be having all the data. Okay, this will be all the data like the PDF, web data, text data, whatever you are having. Okay, then you will extract information from it. Okay, this will be the information extraction part. You will extract all the information from here, and then you will chunk it. Okay, now if you don't know what is chunking, in just the previous video we have seen what actually is chunking. Okay, then we will use an embedding model So why we use an embedding model to convert this chunk data into numerical representation, which is called vector. And then we will store it in a database. It is not a normal database, it is a vector database, but now vector database are the normal databases nowadays. Then what will happen? So now user will have a query. Okay, user will have a query. Again, we will embed it, because why we need to embed it? Because here in vector database we are having vectors. So to query it, again this NLP query has to be converted into vectors, and then it will go to vector database and it will retrieve some documents from it. So we will having some retrieved data. Okay, and then it will be passed into the LLM and we will get some response. Okay, the final response. Okay, it's not like whatever we have retrieved it will be in the response. No, the required information, what is asked in the query. Okay, because it will return some chunks as we have seen in retrieval model. Okay, this is the complete working of RAG. This is called RAG pipeline, RAG flow. Okay, so this is all information I have given you about the RAG. Okay, now let's see in the demo part or the practical part what we are going to build something interesting. Okay, so I am having two documents. First one is the terms and conditions of Krutrim. Okay, if you don't know about Krutrim, it's like a chat GPT from India, which is created by Ola. Okay, and second one is again a PDF, which is terms and condition of chat GPT. Okay, both are having different terms and conditions. We will be creating an agent, and the work of that agent, whenever a user will ask some query, the agent will smartly route that which answer from which document we have to get the answer. Okay, like if we ask a question and we don't have to mention that, okay, ask to Krutrim or ask to ChatGPT. Okay, it will decide by itself, which is the power of agent by its reasoning capability, and then it will basically answer the question based on whatever docs the answer is having. And why I'm using this terms and condition, because Krutrim is very new, and I think that terms and condition of ChatGPT will be also not used as a training material for ChatGPT. So that's why these all are kind of not proprietary data but external knowledge base. So that's why this will be the retrieval augmented generation part, where we are retrieving the information from the terms and condition PDF of Krutrim and ChatGPT. You can use any kind of data source like text file, PDF, or website, SQL, whatever you want. Okay, and then we will also be using the React agent, because I have taught you about the agents, but there we have just seen a basic agent. So we will be using React agent to give you some overview. And at the end, we will also have a task for you, so that to check how much you have understood. Okay, so let's see. That's it from the theory part. So here it is, rag app. I think a lot of cells are there, 24 cells. So we are using a PDF loader because we want to load the PDF. And if you want to see the PDF loader, what you can see, just go to Google and search for PDF loader Langchain, and here you can see all the things you can find easily on the Langchain website. See, this is how we are using the loader. Okay, so you can, so we are using this PyPDF loader to load our PDF. Here I have just loaded my PDF. So just I have uploaded it my PDF. Okay, so here you can just use to split it so that you can convert it into chunks. Okay, so here you can see we have this Krutrim policy, and we have just made it chunks. So I guess there are a lot of pages, 7 pages are there. Okay, not the real pages after chunking. Okay, this one is one document. Okay, as and that the page number. Okay, then we can see the pages of ChatGPT after chunking. So it is of 5 pages, means 5 documents. Okay, so here you can see how we are uploading it and how we are splitting it, means making the chunks. Okay, then we are also using phase. So I have just imported the phase. Then we have created DB. This is a very similar thing which we have also done in the vector store. There also we have used phase. So we have made added the chunks and embeddings. This embeddings is basically the OpenAI embedding. So if I go to the embedding section, so here I can find it. So this is how you can just use your OpenAI key and then use this OpenAI embeddings. This is the variable. And if you don't have a key, you can also use the Hugging Face embeddings. So this is how you can use embeddings of Hugging Face. I have already covered these things in the previous videos, so that's why I'm not going very deep into it. Okay, then we are using a retriever. This is also we have covered in the retriever section. So we are just combining each and everything. Okay, so we are using two retrievers, first one for Krutim and second one was for GPT. Okay, then we are just getting importing some things like format document, runnable parallel chat prompt template. Okay, because we are going to also use the React agent. So this is just a template where I am telling that you are an assistant having 10 years of experience in understanding terms and condition. You will be given some context and you have to find something. Okay, so we are passing the context as well as answer, so as well as question. Then we are using chat prompt template, which is very basic template which we have also seen in the prompt section, where in the very initial of this series, and same for the template of ChatGPT. Okay, now we are using our basically a RAG chain. Okay, you can also use a simple LLM chain that we have covered in the LLM chain section. Here you can see we have just used a simple LLM chain, but I have thought that why don't we use the React agent? Sorry, the RAG chain, because RAG chain is also important, and it's basically made for this retrieval augmented generation. So here you can see nothing new, nothing very different that I am bringing to this picture. This is all in the website only. They have completely developed it and properly documented. You can read it. Okay. So this is how we create a RAG chain where we are passing the context. So what will be the context that we will be retrieving? So the retriever will be retrieving something like this from the retriever Krutim, and that context will be passed here. Okay, and the question will be whatever we will add. Okay, and then the prompt theme will be this one, this prompt theme, this is the prompt that will be passed. Okay, and we are using OpenAI LLM, so this will be a LLM underscore OpenAI. This is just a variable. Okay, if you're following me, this is what I am talking about. LLM OpenAI. This is we are using GPT 3.5 Turbo. If you don't have a OpenAI key, then you can also use Hugging Face, any model like Google 25 XXL or something like that. But if you want to see good results, you should use GPT 3.5 Turbo or any LLM models like OpenAI models. Okay, not only OpenAI models but good models, because that 95 XSL, these are open source model and it's not having that much reasoning capability as compared to GPT 3.5 Turbo and like that or 4. Okay, so this is how we create a RAG chain. Simply we are creating RAG chain, and then the way we invoke the LLM chain, the similar we are also invoking RAG chain could trim dot invoke what is the personal data collected by Krutrim. So this is what like the personal data collected by Krutrim is this. So if you go to the PDF of the Krutrim, you can also, this is a PDF for Krutrim. So here you can see like what are the data that we are being collecting. So where it is. So so let me search data. So or let's see, collect. Search for collect word. Um, mm, mm, mm. So, see, we are collecting and storing like name, phone number, primary location, and email address. So that's why it is saying name, phone number, primary location, and email address. Okay, so this is being, here you can see this is not generating, this is not, the response is not generating due to the knowledge of the GPT 3.5 Turbo. Truthstream is a very new model and the privacy policies, terms and conditions are also very new. So GPT 3.5 Turbo will be not trained on the data of Truthstream. Okay, so solely we are getting this information from the this our external knowledge base, which is this one. Okay, similarly, again, I am asking to the GPT like what is the personal data collected by ChatGPT. So the personal collecting data involve name, contact details, account credentials, and payment card information, user generated content, communication information. That is taking a lot of data. Okay, so again, you can also find it here like collect maybe. Okay, so here I guess see for how we collect and use training data. So these are some information and personal information, all things they are collecting. You can read through it. Okay, you can easily find in the ChatGPT website. Okay, So this is a very basic thing that we have created through chains, and now we will be going through the agent, which is the React agent. So I'm using this chain hub, Langchain hub, because we are trying to pull some prompts. Okay. So this is also we are importing hub agent executor create React agent, because I told you we are going to use React agent. If you don't know about React agent, you can just go to your React agent link chain, and you can easily find the React agent. So this is the chain that we sorry, the agent that we are going to use. Okay, initially we were using, I guess, a very simple OpenAI agent. So at this time we are going to use React agent. It solely depends upon you. Okay, so basically we are pulling this from, I guess, this prompt will be something in the somewhere in the GitHub. So this is the prompt that we are pulling. So prompt template, and this is a basic React uh, prompt. Okay, so this is what the prompt is. But we are not going to use this prompt. We have to modify a bit. Why we are modifying it? Because if you read the prompt without modification, so what will happen now? Like if you ask some contextual question like this, okay, like what is the personal data collected by Kruthrim or ChatGPT, it will give the perfect answer. But if you will ask some out of context question like what is a space, do you know about Barack Obama, then also it will start answering, because using that ChatGPT information, because the information about like black hole, space, or Barack Obama, it's already in the ChatGPT 3.5 turbo models or LLM models, so it will answer from there. So we want to modify the prompt a bit, that we are adding this line that if the question is related to tools, proceed to answer it. Otherwise, return I don't know the answer, because we don't want to answer anything like out of context questions. Okay, we just want to stick to our bot to the questions related to our documents. Okay, otherwise we don't want to answer it. Okay, so uh, we are just using this prompt and just adding this line. Okay, so how this prompt looks like, which is the basic prompt of React, like React agent, like answer the following questions as best you as you can. You have to access the following tools. There will be list of tools. Okay, so we will be showing like which are the tools that we are using. Okay, then use the following format: question, then there will be thought, like what we have to do, then there will be action, which tool I have to use based on the question, then again action input, what input has to be to the action. Okay, then there will be observation, like okay, what actually is the observation, then it will be have a thought. Okay, like I know the final answer, or I don't know the final answer. Okay, and then the final answer to the original input question will be there, and then you have to begin. Then there will be input agent scratchpad and action to determine if question is related to tools or not, and then there will be input whatever question there we are putting. But here we are also using an observation, that we are all, again adding our observation, that okay, if the question is not related to tool, no need to answer, just return I don't know the answer. And this is the input variables. The similar way we use the prompt template, we have seen in the prompt that we have to pass input variables, some metadata, and some modified template. Okay, here all these things are here. Okay, already there are metadata and all things. Okay, we are just adding one line into the prompt. Okay, and we are making a modified prompt so that we can make our own custom agent kind of thing. Okay, now we are having tools. So there are two tools. Again, this is a repetitive part which we have seen in the agent. So the name of tool is Kruthrim Q&A and rack chain Kruthrim.invoke, because we want to run this rack chain Kruthrim whenever question will be from Kruthrim. So useful for when you want to answer question related to Kruthrim terms and condition. And then tool is name ChatGPT Q&A. Function will be rackchain chatgpt.invoke. So the description will be useful for when you need to answer question related to, like it will be like ChatGPT terms and conditions. Okay, so it's very important that your name and the description should be proper. Okay, so it's very important. Then we have to create an agent, create React agent. You can simply find it here, like okay, here you can find that. Okay, this is how we proceed in the React agent. Okay, so create React agent, and we are passing the OpenAI LLM, because we are going to use GPT 3.5 Turbo. Then we are passing the tools and the modified prompt, because this is what we wanted in the input also. Okay, then chatbot agent and agent executor. We want the agent, this agent And tools max iterations means how many times this thought loop should go. Like first of all there will be question, thought, action, action, input, thought, final answer. How many times this should be happened, because it can't be like infinite. Okay, so we have to limit, like max iteration should be 4, and the verbose is true because we have to see what is happening behind the scenes. Now this is what this is the end of our RAG application. Now we have to play with it. Chatbot agent dot invoke, and we are passing an input what is the personal data collected by Krutrim. So here the input is what is the personal data collected by Krutrim. So here you can see the thought is this question seems to be related to Krutrim. We have not mentioned that this question can be answered by the documents of Krutrim or by the documents of the ChatGPT, but smartly it detected, okay, this is the action which I have to do, which is I have to go to the Krutrim, I have to use this Krutrim Q&A tool, and this is the action input, what is the personal data collected by the Krutrim. So the personal data collected by Krutrim includes this, and this is our output, final output. So the how smartly detected which tool I have to use. Okay, now, chatbot agent dot invoke question input: do children under 13 years old have the permission to use OpenAI services? So it had a thought like I should check the Kruthrim Q&A tool for information on the age limit for using OpenAI services. The action is Kruthrim Q&A. Okay, why it happened? Let me tell you, because in the description section I forgot to add Kruthrim here. Okay, I just added. Sorry, I forgot to add ChatGPT. I added Kruthrim. You might have also seen I added it. Okay, but see the smartness. Now here comes the smartness. Okay, then it take the action as Kruthrim Q&A, but again it had again action input. This is why we have this iteration limits. What is the age limit of OpenAI services? The age limit of using OpenAI services is not explicitly mentioned in the provided context. So it used it Kruthrim Q&A tool, but it didn't found. Okay, I haven't given the correct description. Still, it was having that much reasoning capability. Okay, see, then it went to the Chat GPT Q&A, and then it was able to find. So it provided context. So it was advisable to refer directly to the OpenAI official terms and conditions. Okay, so it given some answer, but it again have a thought. I should now use the Chat GPT Q&A tool to find the answer, because it didn't. It was not able to find the answer from the Kruthrim Q&A module. Okay, so now ChatGPT Q&A and the action input was this, and then it get the answer: no children under age 13 are not permitted. So here also you can see if I search for in the ChatGPT, if I search for children, okay, sorry, that is wrong spelling, children. So here you can see our services are not directed to children under the age of 13. Okay, so if I might have, while I was coding at this point, if I would have done like useful for when I need to answer question related to chat GPT, at that time I have added Kritim here. So if I have not made this mistake, then in the first go only, it would have gone to this chat GPT Q&A. But by the mistake, we have learned a lot of things. Like, see, if I would have not done this mistake, so I was not able to explain that how good this React agent is. Okay, so at the end, whatever happens is for the good only. Okay, so this is what ChatGPT Q&A, and it gave some output. Now let's see some questions which are out of context, like tell me about Spider-Man. So the thought was the question that tell me about Spider-Man is not related to Kruthrim terms and conditions. So it went to ChatGPT Q&A, then tell about Spider-Man. The provided context does not have any information. So thought was the question tell me about Spider-Man is not related to Kruthrim terms and conditions or the tools above, because it already checked the ChatGPT Q&A. So then the final answer was I don't have the answer. Why? Because of this line that we have added observation. If the question is not related to any tools, just return I don't know the answer. If we have not added this answer, this line, or if we have just used this prompt, this is a system prompt. Okay, we have to pass it to the agent. So while we are initiating our agent, we have uh, while we are creating the agent, we have passed a prompt. If I have passed just the prompt without any modification, then this type of questions would not return the answer that we want. Okay, it will return some genuine answer because it has all the knowledge base of GPT 3.5 Turbo. If you are go to ChatGPT and ask who is Spider-Man or what is Spider-Man, definitely it will answer. But in our chatbot, we don't want to answer it because we want only the contextual answers. So that's why we have our own custom agent, and we have added this line, okay, if the question is not related, just return I don't know the answer. And because of this, we are getting this I don't have the answer. So that's why we have modified the prompt. So this is just a simple RAG based applications. Okay. So you can just make a API endpoint and just deploy it, and you can use this at whatever input you are getting. So it will be placed here as a placeholder, and whatever the information which will be in the output, you can show it in your application in the front end part. Okay. And this is what backend, and I also work at backend, so I mostly focus on the backend part. Okay. And obviously this is a soul. Okay. But still, if you don't want to create APIs or complex front ends, you can use Chainlink or this is what I'm talking about, Streamlit. So here you can, it's a very faster way to build whatever LLM apps are there. You can create chatbots very quickly, or also you can use Chainlint, I guess. So Chainlint, yeah, this is what. So you can use this so that you can build your conversation AI modules very quickly. Okay, this also where you can get the front end like this. It will look something like this. Okay, and the back end we have just discussed how we can create it through in this RAG application. Okay, so this is a very cool thing you can create, and just if you want to flex with your friends, and you can definitely use this Streamlit or Chainlink to create the front end of it, and you can use the backend for it, and see how smartly we have used the React agent to basically route to the knowledge bases. Like we don't have to tell explicitly that every time that okay, which document you should use to retrieve data. Okay, the agent was smart enough so that it can basically it it actually knows that where I have to look up. Okay, so that's it. Like you should I think you have also got some information about React agent, and also you can explore about React agent here. Okay, um, but what actually is a task that I was talking in the at the starting of this session. So here you can see we have not used memory. Okay, in this whole chatbot, only one thing is missing, that is memory. All these questions are discrete. Like if I ask a question, what is the personal data collected by Krutim? This is a discrete question. If I ask another question like, can you tell me where the data is going? So it doesn't have a conversation capability. Like, okay, it doesn't know that, okay, in the previous question, it was talking about Krutrim. So the next question is also related to Krutrim, not ChatGPT. So that kind of conversation capability comes from the memory. And I have already covered memory in the previous video where we have seen a lot of memories. So try to add memory to this chatbot. This is your task. And if you want a specific video, but I can do it, but please use your knowledge, because it's very important to collect the whatever bits and pieces knowledges you are having. You have to combine it and create something fruitful, which is called engineering. Okay, so try to add memory to this chatbot, and let me know in the comment section if you are able to do it or not. And then I think the RAG application will be completed. Like if you add a memory to it and everything is done. I know a lot of things are there, like semantic cachings are there. Caching is like, let me give you a basic example. Like if you ask a question, like any question, like let's suppose if you ask some questions. Okay, like we are having some question one. Okay, and you ask to the LLM. Okay, it took around, let's suppose, 1 second to answer your answer, and here is your answer. But what actually happens in caching, we store this question as well as this answer in something like cache. Okay, this is the AI data, or the human like human question and AI response, something like that, and it will be stored in the cache. Okay, and now in the next time, if the same question is asked, okay, same question or similar to same question, like if they are semantically closer, okay, it doesn't need to be completely equal word to word. Okay, but if the semantically they are same, like what is the capital of Australia, and can you tell me the capital of Australia, or capital of Australia? All three questions are semantically equal. So now it will not go to the LLM. Okay, it will just go to the cache, and it will give the answer and not taking 1 second. It will be very, very, very less than 1 second, because we are using the cache to answer it, not the LLM. So this is also included, but it basically not comes under the basic part. But definitely you can also implement it. Just go to here and search for semantic cache, and it's I think very easy to implement. It's not a huge thing. So here you can see LLM caching integration, in-memory caching, Redis cache, SQLite cache. You can just use in-memory cache for as of now. But we will see in some of the video how caching improves the functioning of RAG-based application. But as of now, just try to add memory to here so that your RAG application will be completed. Okay, so that's it. We have seen a lot of things in last two videos. So this is all the basics you should know about LangChain as a starter. And I know a lot of other topics are remaining, but this is the basic. If you know about it, you will have a very good basics of LangChain, and you can create some pretty fruitful LLM based applications. Thank you, and please subscribe and comment and share, and stay tuned for a lot of more LLM related apps, not only LangChain but Llama Index and all the other different frameworks which are helpful to create LLM based apps. We will keep posting new videos. So that's it. Stay tuned. Meet you in the next video. Till then, bye bye. Thank you.